Today I'm going to be talking about Rcpp. So this is not statistics, mathematics, this is more computing. And it's about overcoming some of the drawbacks that R has in the community. It's well known that it can be slow at times, but Rcpp provides tools to allow you to overcome that by writing C++ code that can be used in R, just like any other function. Does anybody here have experience with C++? Has anybody here tried learning C++ but gave up because they just didn't like it? Okay, I got one. And I got a half of the nod in the back. Good. Well, later on you'll see that this particular package provides some functionality to make, if you're comfortable coding in R, it makes it as easy as possible to transition into C++. Honestly, even if you're writing just regular C++, using these C++ packages is really helpful if you have a strong R background. So I've adapted today's presentation from 3 main sources listed here. I encourage you to check them out. And the structure of today is to introduce Rcpp, motivate its use to you, highlight some of the main points that you need to be aware of that you could spend hours reading about, but I just want to make it as obvious as possible. Run through some examples, and then the final few slides, I might not rush through them, but I'll breeze through them. You don't necessarily need to take notes. Like he said, he's going to put this on GitHub. But I wanted the final ones to be kind of a cheat sheet for your quick reference, so you don't necessarily have to go through these 3 sources like I did. You can just refer to my slides. Okay. I apologize for being cut off on the bottom. John, is there a way to, no?
No.
Okey doke.
Sorry.
It's all good. So, R is an interactive environment for data analysis and visualization, and it's an expressive programming language. So that means, interactive means that as you're typing and hitting enter, you're getting the results of what you wrote. Okay? In C++, you need to write a file, compile that file, call that file, an executable file, and then start giving it inputs and it'll run. That's not very fun for the 2 people that kind of like raise their hand and put it down. That's probably the main reason that you kind of like pulled your hair out and said forget about it and move into R. The interactive nature makes it easy to work on the display, and it's one of the main strengths. However, one of the main drawbacks, the one that people know the most, is that loops can be really slow in R. And the main reason for that is the way that it manages memory. So every time, when you define a variable and then you call that variable in C++, there's something called a pointer. So it's literally the physical location on the hard drive where that information is located. C++ is going to point to it to figure out what the value is. There's problems with that because if you accidentally overwrite it, now your program is broken. So because R was written with data analysis in mind, they made it so that they would never operate on the original value. They would make a copy and then perform the operation. That's good if you're doing a data analysis. You don't accidentally overwrite your data. However, it can cause a lot of significant slowdown, noticeable slowdown in certain situations. So here's a little illustration of, R is also written in C if you weren't aware, but I've made a variable x, which is just a vector from 1 to 1,000,000. I then made another vector that repeats it 3 times, then I made a list that repeats it 3 times. If you look at the size, it's 4 megabytes. This is 12 megabytes. And then if I do Z, this is 4 megabytes. I know what's at the bottom of these slides, I've practiced this. So this is kind of closer to C, right? A lot of the vector objects make copies of the values, whereas this one is using pointers to just fill it in 3 times, but it only uses it once. That's the same thing that happens here. If I do the object size of X and Z, it's still 4 megabytes. Here, I'm going to get 16, 4 times 4. So when you're writing in functions in R, that's just kind of an example of how sometimes R functions, the C function specifically, will make multiple copies of something. This is the simplest example I could come up with. Okay, not cut off. Whew, okay. Let's illustrate the speed gains possible by using Rcpp. And all I'm doing is 1 divided by 1 plus x. And I've done it 5 different ways. If you have questions about what the differences between these are primitive functions, the curly brace and the parentheses. But each one is doing the exact same thing, but in a different way. And one of them is even just nesting the previous one inside of this. But if I pass this into micro benchmark, unfortunately that is cut off. Let's see. So actually, John, I know maybe I should just plow through. But can I just, instead of doing it full screen, can I have the original thing? Because I want everyone to see what I have here. I'm going to do this, because I want everyone to see the full slides. I don't want to just have you sit here for a half hour while I talk about what could have been seen by everyone in the room. So I wrote this, call the Rcpp package, and you can write C++ code using the CPP function, right? This is how you would do the exact same thing as what we had done above. You see here that in this case, I have 1, 2, 3, 4, 5 functions. The F1 seems to be doing the fastest, the other ones are a little bit slower. Now if I define a new one that is FCPP as opposed to F1, 2, 3, 4, 5, okay, and I again pass it to the benchmark, you can see here that the C++ function is outperforming, the fastest one is doing over 18 times faster, okay? Any questions? My style, I welcome interruptions, so if you have any questions as I go along the way, please feel free to raise a hand. Yeah?
I'm just curious, as a newbie, that CPP, is that something relatively new that was introduced, or is that...
Rcpp, the package?
Rcpp, yeah.
It's not, well, it depends what you mean by relative, but it's been around for several years.
Oh, it has?
Yeah, it's been around for several years. And so CPP just stands for C++.
Got it.
All right. Another example is the Fibonacci sequence. Everybody's heard of this if you've taken any kind of a higher sequence in calculus math class. So it's defined as 0 for the first observation, 1 for the second, and then the previous 2 values added together for every other value going forward. This is notoriously slow, and if you try to do this in R, you'll see just how slow it can be. So I've written this in R. And if I just copied and pasted it and made a few small changes, I'm going to illustrate the differences between R and C++ coming up. But I just copied and pasted it. It looks almost identical, but I've done it in C++. And now when I benchmark them, over 200 times faster. So you can see here the way, because I have 2 values, and then I need to copy those values in R and add them together, and then copy those previous 2 and add them together. And even calling that function all takes time in R. But in C++, because it's using pointers and things like that, it's a whole lot faster. Streamlined, I would say. Now, I've been using this CPP function. You know, it's nice for presentations, but in general, you're not going to be especially if you're writing a more complicated function that's not more than like 4 lines, you're probably going to want to have separate C++ files, okay? So for that, we're going to use a different, so all of the C++ files that we write have to have this on the top. Include Rcpp. This is kind of like if you're an R user typing library tidyverse, right? This is how I bring in all the functions to make them available to me. Using namespace rppp, don't even worry about that. It just saves you a little bit of time. And then also, if you want this function to be available within R, so you can write functions that are available to other functions. But if you want to export them so that they're available to you when you're using the console, you need to put this little line here. And just pay attention that this little space between the 2 slashes, that's mandatory. You have to have that. And you'll see this come up in my subsequent slides. Another nice thing about Rcpp is that it allows you to actually embed R code in your C++ file using this special comment. So this /R and */. You can put R code, proper R code in between, and it'll run that R code. which is really nifty as you start getting more advanced, okay? You source the code, source CPP, path to your C++ file, okay? And once you've done that, and I'm going to have some examples, you're going to have a function that you would use just like a regular R function available to you in R, but that it is using C++ compiled code. So let's do a couple examples, right? The first example is just writing a function for the mean, okay? So I'm going to call it mean C. All right, it takes in a numeric vector. I define n as the size. Total, I have to initialize the total, and then as I iterate through the vector, I'm going to add up all the entries, and I'm going to divide it by the total. Okay. And then if I compare the one that I just wrote to the one that's native to R, you can see that the average time is much lower than the default one. Okay. This is maybe not significantly lower, but it is faster. Any questions?
Yeah. So
yeah.
If you look at the max,
oh yeah. Mm-hmm.
What's going on with our version having a much lower max?
That I don't know. To be honest, I'm not sure, but.
So a lot of time with
yeah.
the minimum and maximum is it might be a very large range. So that could be that just garbage collection was happening at that step when you did the mean.
But on any given iteration, because I'm repeating this, with micro benchmark, I'm doing it several times, 100 times in fact. One of those times took substantially longer.
Are you saying that's the first iteration where it includes all the startup? Maybe?
Possibly, yeah. I'm not a computer scientist, so if I were, I might be able to tell you exactly how memory allocation or something is being done. But in general, on average, C++ is going to perform a lot faster.
It quite often is other things that are happening on the processor that you don't necessarily have control over. So anytime you're looking at timing stuff, it's always sort of a way to the hand, unless you build machines that are locked down that are runtime.
Right. Any one instance isn't really descriptive. It's the maximum one, but on average, it was faster. So it just repeats for the people who are recording. Sometimes there are things happening internally on the processor that you don't have control over. So to summarize, all right. Okay, so now let's talk about some of the real differences between C++ and R. For anybody who doesn't have any experience with C++, this might be eye-opening for you. C++ is a program that's compiled. Like I mentioned at the beginning, you write a file, you compile it into an executable file, and then you call that executable file to make it run. In R, the objects, after compiling code into an object, the object is linked into an executable, possibly together with other libraries. Pointers and memory management are handled very differently, okay, in C++, but there is something that if you are going to get more into C++, there's a standard template library, which are very highly optimized algorithms for common things that you might be doing when constructing a function. They recommend you use that. One of the great things about R is that it's dynamically typed. So I just have to type x equals 3.14. Or x equals foo. And R understands the context. It understands that this is a character and will automatically define it as a character. It'll know that this is a floating point double, and it'll automatically do it, and I don't have to get down to the nitty-gritty of defining everything. However, in C++, you have to do that. You have to say double x, and it's to initialize it, and then I have to assign it a value. Okay, I have to do string or char, this char character. I have to say car x, and then assign it foo. In C++, you have to be very explicit, which is sometimes a bit of a pain. Okay. And also another thing that's different is that in C++ we have something known as scalars, which is like a single element, okay? Like the number 1 or the name Luke, right? But in R, there are no scalars, there's only vectors. Sometimes that vector has a length of 1, but it's always a vector. And so when passing variables, there's something to be aware of when you're coding. When passing variables, you need to pass vectors back to R using Rcpp. Another thing, C++ has lots of vector classes. I've listed them here, and you can come back to refer to them, and also the scalar and matrix equivalents. All right. Another thing, our objects have arbitrary additional attributes. Used to store metadata about the object, like what package it came from, what class is this object, all these other kinds of things can be very useful if you're an advanced R coder. C++ attributes can be queried and modified with the .atr, and this also provides something called .names as an alias for the name attribute, and here's an example of that. So I could create a numeric vector with attributes, and here is the numeric vector I created. The names are going to be A, B, C, so A is 1, B is 2, C is 3, and then I could have additional attributes, some arbitrary attributes that I come up with, okay? But this is how you would do it using Rcpp. All right. Okay, another thing to be aware of when writing in Rcpp is that C++ and R handle missing values very differently, okay? And you're going to need to know how R's missing values behave in C++ and how to get and set missing values in vectors within C++. So I'm going to create a list, and I'm going to define an integer missing, a string missing, a logical missing, and a numeric missing, okay? And I'm going to return the list. Now, when I return that list, this is NA, NA, that's cool. I wanted them to be missing, but the logical is true, and numeric is missing. So this all seems fine. However, even if those are looking like they're behaving the right way, aside from the logical, there's still some things you need to be aware of, which I'm going to cover here. So, specifically that Boolean, why did it convert from a missing to a true? All right. In C++, there's only 2 possible values for a Boolean, true or false. In R, it can have 3, true, false, and NA. So if you have something listed as NA, right, an R missing value, an R missing logical, C++ is going to be confused and it'll be converted to a true, because it just doesn't have an NA value. All right. For integers, something that's interesting is that the missing value of an integer in C++ is actually the smallest possible integer value that you can have. So if it's going to be listed as missing, C++ makes it the smallest possible integer value. R doesn't know that by default, right? It doesn't understand that. So if you pass it a missing integer +1, you're going to get this really, really negative number, right? This is the smallest possible integer that my machine can handle +1. Okay? So just either, we're working with scalars. Remember, scalars don't exist in R. So you can overcome this by using vectors or just being super careful with your operations, okay? Making sure that you're aware of that. Doubles, you can get away with ignoring them because in R, the NAs are a special type of floating point number, and floating point numbers are which is understood by C++. So if you do logical operations with these nans, it's always going to return false, so be aware of that. But whenever you're doing arithmetic operations, it correctly returns nans again. So just be aware of this if you're going to be using Rcpp in any kind of Boolean. Did I see a hand over here? No? Okay. All right. Okay, and like I said before, you could instead include these in a vector. So I have a numeric vector, an integer vector, a logical vector, and a character vector, right? And let's see. Okay, now it's correctly made that an NA. So by just including all the objects as vectors as opposed to scalars, you overcome a lot of these issues. So for the C++ user, that might seem strange, but for R users, it should be a little bit more natural. Okay. We can let's check out whether the objects in the vector are missing. Okay. I can write this function that will check them and return whether it's true or false. Okay. Sounds good. I wrote that function. Or I can use what's called a sugar function, is NA. This is something that is included in this rcpp.h the package, right? So it comes with these pre-built functions that'll write it for you, which is a lot easier to write as opposed to me writing a for loop and checking every element. I can do that. So I said sugar. What does sugar mean? Does anybody here know what syntactic sugar is? Yes. It's on the slide, so you can shoot it. It's basically syntax within a programming language that is designed to make things easier for people to read or to express. Right? It just makes it, instead of me writing a long for loop, I can just write is NA, and it's understood that it's going to do it element by element. It makes the language sweeter for human use. It's easier to read and write. Rcpp, the package for R, includes a lot of syntactic sugar to ensure that C++ functions work very similarly to R. I could imagine some guys who were R users that wanted to make the C++, and they would write a function that was like 5 lines shorter, and they'd be like, sweet. And I'm like, oh, sweet. So it's the sugar, all the syntactic sugar. It really makes it a lot easier to make that transition. Great. So this is the part where we're now just kind of going through a cheat sheet. I want to go quickly through this, but it's here and available to you for your reference. There's lots of math functions, also different summary functions, vector summaries, finding values within a vector, dealing with duplicates, and also random distributions. So you can, if you know how to do all this stuff in R, you know how to do it in C++ now, which is really, really nice. All right, and also all of the basic arithmetic logical operators are vectorized, meaning that they operate element by element across a vector, which is something that you would have to otherwise write a for loop in C++. Major pain in the butt. Now you have vectorized functions, a lot easier. Okay, and here's an example of 2 separate functions. One is written in C++, and the other one is using the sugar. So it's basically, I take a vector of y's and try to find each element's distance from another number x, and by squaring the difference and taking the square root. This version versus this version, if you're an R user, this one, if you're anybody, I think this one looks a little bit more appealing. It's a lot easier to write.
It's kind of lambda functions in Python.
Excuse me?
These sugar functions, like
Yes.
lambda, something similar to lambda functions.
I'm aware of lambda arithmetic, not arithmetic, but operations, like functional programming, but I'm not familiar with any kind of lambda functions in Python. I'm not a Python.
So your answer basically is yes. So
The answer is
functions
yes.
allow you to basically perform vectorized operations in
Okay.
Python. Everything pretty much in R is vectorized by default.
Right. Okay. Also, this is just, again, things to encourage you to use these things. The any and all functions are lazy, meaning like if I wanted to find out if any of the numbers are greater than 10, and I start at the first element and it's 3, 12, 5, 7, other ones that are not lazy are going to check the whole vector and then stop. Lazy ones are going to go, and it's the first time that it fails, it's going to stop. So it saves computational time, and if you have a lot of repeated operations, having lazy implementation is definitely desirable. So these are implemented in a lazy way. Right. Let's skip through this. Okay, let's just do the final example. for a Gibbs sampler. All these, I don't want to waste your time tonight with this, but the logical summary functions, that's all there. But here we have a Gibbs sampler written in R, okay? And then I just copied this code and rewrote it by declaring all the variables, right? I have to define like a double x and then give it a value. I have to declare them. I use the parentheses instead of square bracket. R uses this, C++ uses this, and then subscript the results, because in C++, if I'm using a vector, I have to say I want the first element of that vector if it's going to behave like a scalar. Okay? I paste it, I do all three of those things, and look, it's almost identical to my R code. But when I run it, it's over 21 times faster. So if you're especially, this is a great example, if you're doing a lot of simulation type work and you're willing to put the time into to coding this up, maybe 20 seconds isn't worth it to you, but if you're going to be doing this over and over and over again with different data sets, it might be worth it to you and your company. So that is pretty much it. I have a few slides on how to implement Rcpp in our packages. I just wanted to include it here so that when it goes up on GitHub, you guys have access to it. But there's a couple of things you need to be aware of. So thank you for your time. I appreciate it. Any questions? In the back.
What would be the difference between just using C++ versus using RC++?
Well, can you give me an example? Like, give me an example where you think there might be no difference, because I can think of several. But
Well, just like any sort of computation.
well, as I said, C++, the usual workflow is open text document. Code.
Right, but once I
compile.
know that.
Well, now, because if I want to use the functions that I've written, I need to run an executable file, right, in C++,
Right.
right? If I use Rcpp, I can define functions. Let's see. I've created a function called Gibbs CPP, which I can then use interactively in R on my console. I don't have to find a new file, run the executable, pass it values, don't have to do any of that. I literally can just call the function within R.
So in this example, you have to import it or bring it in though, right? Like
Well, I mean, I have to define it.
you have to define it
Mhm,
first, and
mhm.
then you can use it interactively.
Exactly.
Okay.
And so
You don't have to do it with every snippet of code that you put
no,
in.
but
Just
as
once.
long as you have your C++ document has these 3 lines at the top,
Yeah,
it's gonna take the result and make it accessible to R.
okay.
Cool? Yeah, great questions, I appreciate it, yeah.
And can you pass, like to these functions written in CPP, can you pass, like the R functions and whatnot? Because that's what I think.
So you mean, what do you mean by passing the function? I can pass it the result
They
of
have
the
like a
function.
ton, like stat functions and whatnot. Can I pass that to a CPP?
Yeah, actually you
Use as a
can.
pointer?
Yes,
Okay.
you can, because those objects are, they have slots, they're lists basically, and you can pass it in and there are ways to access it. So you basically want to pass it the entire summary results and then write code to operate on that summary, on the results of a statistical, like a regression or something like that? You want to take a
No, I'm wondering, like, I'm just wondering on
all that
how,
object?
because you're saying you're using C++ functions within R, can I utilize like some of the R functions in the
Oh, yes.
CPP?
I think I had a slide on that where there's a slash triple star R and then a star slash. If you, that's like
Okay,
it's
so
almost
that's
like a code chunk in R Markdown,
Mhm.
but it allows you to write some R code directly in the .cpp file, and using those any variables that exist in that environment at the time, right? I think you can do that. Yes.
What kind of compiler is it being used here?
Oh, good question. I can't remember off the top of my head, but I know that Hadley Wickham's R packages mentions that there's a preferred one. There's a preferred. So I have a link.
Oh,
Say again.
GCC is the
Yeah,
preferred.
thank you. GCC. And, but check out those links. I think I linked to it in the slides, so if you download it. You can-
And do you bring it in as a .exe or is it a DLL that gets created and then you bring it into R?
.exe?
Yeah.
No, it's doing all that for you. It's creating, so I'm writing just the CPP
Right.
files, and I'm sourcing them within R.
Okay.
Using
You sort of
source
compile them?
It compiles it,
Uh-huh.
creates a compiled copy,
Okay.
and then points a function to that code.
I see. So you're not compiling outside?
No, I'm
Okay.
not compiling outside. It's really convenient. You bypass all that.
Okay.
It's great. There's one thing I may have glossed over, which is that in R, everything is an object, right? Even functions, except these ones. If I create a function using Rcpp, I can't save it to a .r data file and then have someone open it and it's available to them. They're gonna have to recompile that all themselves. That's just something I wanted to mention. Did you have a hand up?
I've got a question, Luke.
Yeah.
So in the old days before RCPP, when you were writing just straight CPP,
Uh-huh.
everything came in as an S expression
Mhm.
or a sexp.
Yes.
I don't see any of that in your RCP. Is that sort of abstracted away S expression
Yeah.
completely?
Well, it's definitely useful. You talk about like the regular C interface for R.
Yeah.
Yeah. So that's still, I mean, it's still available for developers, but I think it's mostly used by the base R people. And in terms of C++, because C++ is closely related to C, R can understand it, but they just created something that's a little bit more. Yeah, exactly. And you can see it is a lot, this learning curve is a lot less steep than with the
Because with the S expression,
SCSP,
you would have to
yes.
bring it in, you would have to cast it to a particular type. You'd
Yeah.
have to know ahead of time what type
Exactly.
it was. You'd have to protect it and then unprotect it.
Exactly. All the things that people hate about C.
Yeah.
Right? So they've taken away a lot of that work, so they're going sweet, making it easier for your work. Any other questions? All right. Thank you guys. Really appreciate your time.